Hello, so today I'm looking at M3 International A-Level January 2016. This is question 3. So I have a car of mass 800 kilos is driven at constant speed v around a bend in a racetrack. Around the bend, the track is banked at 20 degrees to the horizontal, and the path followed by the car can be modelled as a horizontal circle of radius 20. The car is modelled as a particle. The coefficient of friction between the car and the tyres and the track is 0.5. Given that the tyres do not slip sideways on the track, find the maximum value of V, and this is worth 9 marks. So the very first thing, as always, I will do is draw a lovely big diagram. So I'll draw the track. I'm going to draw it at quite a big angle because it just means that it's a bit easier to see what's going on. So this angle is 20 degrees and the weight will be 800 G. I'll draw in this dot here, and this angle is also 20 degrees. It's whatever this is. Then, because this is touching a surface, then I will have a normal contact force. The car, if it's going as fast as possible, would tend to try to make the circle go bigger and bigger and bigger. So that is what it would tend to do. So friction will act against that down the slope. And so here I have R divided by 2 because mu was a half. Then I have the acceleration towards the centre of the circle, which is going to be v squared divided by the radius of the circle. And they told me that that radius was 20. So I've got v squared over 20 here. Okay, and so I'll just put some more dotted lines in so that I can see where which angles are which. So if that's 20, that's not 20, that's 20, that's not 20, that's 20. Okay, you'll notice I'm not going to work out the other angle, even though it's quite a simple calculation, 90 minus 20. The thing is, if I work that out and then use that angle, if I make a mistake, then I'm going to lose so many marks on accuracy, it's untrue. So I prefer to use the angle that I've been given and then use sine or cos as appropriate. Now, what you might be tempted to do is to resolve in this direction and say R equals 800G cos theta, cos 20. Now, that is not true though, because in this direction, there is actually some acceleration, because the acceleration is here and therefore will have a component in this direction and in this direction. So if you are going to resolve in this direction, then you need to say R minus 800G cos 20 equals the mass times the component of the acceleration in this direction, which you can do, but that is generally not a good idea. Well, I don't know, you can do it, it will work in the end, but you might find it easier to use the direction perpendicular to the acceleration, so basically forces up equal forces down, and then use this direction. So you're saying forces this way minus forces that way equals the mass times the acceleration. So let's go for it then. So if we resolve vertically, then I have R cos 20 equals 800G plus R over 2 sine 20. And rearranging this to give me, I would like R really. I'll leave the 800G on the right hand side. Take away R over 2 sine 20 from both sides. So I end up with R. I will end up with R written twice, so I'm going to factorise that R so that I've only got R written once. And so here I've got cos 20 minus sine 20 all over 2. Okay, so now I can work out what R is by doing 800G divided by this thing. Oh dear, it's going to be terribly ugly there if we do a fraction divided by a fraction. So actually I will make that all over 2 and pop a 2 there, so that I'll end up with the top of this fraction will end up on the bottom here, and then the bottom of this fraction will end up on the top, like this. Okay, and this is horrendous to deal with and to write down, so I'm just going to pop that all into my calculator and then save it into the memory of the calculator. So I've got 800 times 9.8 times 2 divided by 2 cos 20 minus sine 20. Oh, I think I'm going to need to close that bracket there, because otherwise my calculator will complain. And I end up with 10199. That seems very big indeed. Let me just check that that was all okay. Right, let's try typing it in a different way. 800 times 9.8 times 2 divided by 2 cos 20 minus sine 20. Oh yes, okay, that's okay. Right, store A. Okay, then I can resolve in this direction. So Newton's second law this way. So forces to the left minus forces to the right equal the mass times the acceleration to the left. So I've got r sine 20 plus r over 2 cos 20 equals the mass times by the acceleration. So here I get 80 divided by 2, which is 40. And so v squared is going to be 1/40th of r. And so I'm just going to write this value in, but I'm going to recall it from my memory so I don't have to keep typing it in. So, but I'll just write for the examiner what I'm going to do. So that's r sine 20 plus 10199 over 2 cos 20. And I divided by both sides by 40, so this will give me v squared. So then I'll need to square root the whole thing to give me v. So, right, let's try typing this in. So I've got a sine 20 plus a over 2 times cos 20. That's that stuff, which is essentially what goes in this bracket. Then I need to divide it by 40, and then I need to square root it to give me this maximum value of v. So then I get that v is 14.4, or I could just round it to 14 meters per second. Okay, so that part of the question, oh, that's the whole question. That's worth 9 marks. I hope you found the solution helpful. Do click like if you liked it, and good luck with your studies.